Okay, let's get into these questions over here. The instruction here says expand the following expressions. We can also think of expand as the word simplify. Okay, simplify, which basically means take away the brackets, make it as simple as it possibly can look. No brackets, because brackets means we still need to multiply. So in this first question over here, we're going to multiply the first term with all three of the terms we have in the second bracket. So we should get a cubed plus 2a squared plus 4a. And then we're going to do the same at the bottom. We're going to multiply all of these by -2. Now, many of you guys have a tendency of leaving behind that negative as you go. Please do not do that. It's very important that the negative comes with, otherwise our answer doesn't come out the way that it needs to. Okay, so we'd get -2 times a squared will give us -2a squared. And then we still need to multiply the next one by a negative as well. So my next answer isn't going to be plus 4a. It's going to be minus 4a. So we need to make sure that we're multiplying properly. Then I'm going to get -2 times 4, which will give us -8. Then I can add like terms. 2a squared minus 2a squared will give us 0. 4a minus 4a would also give us 0. So our final answer here should be a cubed minus 8. Okay, you will get 1 mark for distributing properly and 1 mark for simplifying properly, the last answer. All right, in this next question that we have over here, I want us to note how there's a negative on the outside. There's a negative on the outside, but there's also an exponent over here. Which are we going to take care of first? Are we going to remove the exponent, or are we going to remove the negative first? What do you guys think? Isabel says the exponent. Mawande says exponent. I agree. Okay, good. What does PEMDAS actually mean? What does PEMDAS actually mean? I know many of you guys learned BODMAS. BODMAS is one of the things that we've learned, or PEMDAS. You can also learn BOMDAS. It doesn't matter. All of them mean the same thing. It's just a way for us to remember the order of operations. Okay, in this case, we know we must always deal with brackets first. In PEMDAS, the P stands for parentheses. Parentheses is the same as brackets. Parentheses and brackets are the same thing. Yes, Slay Queen, how can we help you, my sweetie?
Oh, ma'am, I was going to say parentheses, exponents, multiply, division, addition, and subtraction.
Perfect. Excellent. So we know that that E stands for exponents. In this case, the brackets in BODMAS also mean exponents, but nobody really knows that. But thank you. I don't think most people know exactly what it stands for. They just kind of see it. They're not sure what it's for. But thank you, Slay Queen. Yeah, see, the math is paying off. It's paying off. We see, guys, Slay Queen knows things. Don't what is it? Don't undermine her. The English was not English. Yes. Don't underestimate the Slay Queen, guys. She knows what she's doing. All right. Yes or no? Can I take that squared on the outside, square these things like this? Yes, that's the word I was looking for, Fense, underestimate. Can I distribute my squared into the bracket like that? Yes or no? No, absolutely not. Because we know we can't do that. Okay. Yes, Butle, that's what we're going to do. Okay, we need to make two expressions. The same way that x times x is equal to x squared. If I have x plus 2 multiplied by x plus 2, that gives me x plus 2 all squared. It gives me the same thing twice. So if I have the same thing twice over here, that means we're going to have to break it up into its two parts. But please, guys, do not forget that there's a negative sitting in front of this thing. Okay, there's a negative there. So I'm going to get 2x minus 5, open brackets, 2x minus 5. Okay, now we are going to look at the brackets first. We're going to make sure that we distribute the brackets first. So we can do FOIL, 1, 2, and 1, 2. Now I'm going to keep this in a bracket because my negative is still sitting on the outside. I have to make sure that once I'm done, only once I'm done foiling, then I multiply the negative in. Right, so I should get 4x squared minus 10x minus 10x plus 25. All right, so if I simplify that, I'm going to get 4x squared minus 20x plus 25. And only now will I multiply my negative in. So I should get negative 4x squared plus 20x minus 25. All right, the reason why this question is only worth 2 marks is because there's a shortcut to doing this. All right, and I know that I just said we shouldn't do this, but you are allowed to do this because there's a shortcut that you can learn in grade 9 on how to multiply these out. So if I have 2x minus 5 all squared, what I can do is I can square the first number, square the second number. So I'm going to get 2x squared. So that's going to give me 4x squared because the 2 is also squared. And over here, I'm going to get negative 5 all squared, which is going to give me positive 25. And then to get the middle term, I'm going to take 2x times negative 5, which will give us negative 10x times 2, which will give us negative 20x. And all of this is still to a minus on the outside. All right, that should give us negative 4x squared plus 20x minus 25. So because there's a shortcut, they're not going to give you all the marks if you go the long way around, because the shortcut is something that's taught in grade 9. But if this method, you feel like you're going to mess up this method and you would rather go the FOIL way around, do not try new methods, guys. We spoke about not trying new things during an exam. Things like trying to figure out what adding fractions are, even though you're not sure, but you think you know. No, we don't do that during an exam. That's for things you do when you're practicing. When we get to the exam, you do the thing you're most comfortable with to ensure that you get the most marks. So if you have been taught how to do this method, you would get 1, 2 marks. But if you know how to go the long way around, if you do this method, this one that ma'am just did here, they will still only give you 2 marks, but they are 2 marks you cannot afford to lose. So go ahead and do it the long way around. Give me a thumbs up if what I'm saying makes sense. We don't want to leave any marks behind, but more than that, we don't want to make a silly mistake because we are trying. Yes, you do. You do. You get 2 marks for each of those. Okay. We do not wait until exam papers and test papers to try out our skills on certain things. No, that's for practice. In exams, we do what we are 100% comfortable with to make sure that we get all of those marks. All right, excellent. Let's talk about question 3 over here. Let's talk about number 3. All right. I just want to take a screenshot and put it over to the side because I'm just realizing now that I can't see it 100% and there's no space. Okay. I'm just going to take a screenshot and I'm going to move it over to the side quickly and we're going to talk about it. All right. So first thing we need to note is that A over 2 isn't something that I can put into my calculator. It's not something that I can just easily multiply. What I'm going to do is I'm going to rewrite A over 2 as 1 over 2A times A. They both mean the exact same thing. We're going to do the same with A over 2 over here. We're going to get 1 over 2A. Now, I know that I now have to FOIL because this isn't a difference of, yes, it is a difference of 2 squares. Right, I now know that I'm going to have to FOIL. So I know I'm going to take A over 2 times A over 2. I know that I'm going to have to go half multiplied by a half. Now, many people sometimes get confused and they make that 1. It's not 1. If you are struggling with fractions, pick up a calculator, punch that into a calculator. A half times a half should give us a quarter. And then A times A will give us A squared. All right. So if we're not 100% sure what's supposed to happen here, just split them, make them into the fraction and then the variable so that we can see the difference between the two. Okay. And then I'm going to get A, or a half A times -1 is going to give us negative a half A. Then we'll do the bottom. 1 times a half A will give us positive a half A, and 1 times -1 would give us -1. All right, so I know that half a, negative a half a plus a half a will cancel, right? So we will then get a quarter a squared minus as our final answer. And again, the only reason they're giving you these marks is because you have foiled out properly. But because this is already dots, we should be able to recognize that it is dots. They're only going to give you 2 marks for the final answer. These are accuracy marks. Okay. Isabel, you can. It's okay. Yes, it's okay to do that. But Mawande, is it okay if I wrote it? No, because the instruction is to simplify, and 2/4 is not in its simplest form. Okay. Oh, is that a squared? Oh, sorry, I saw 2/4. A squared over 4, correct. Yes, you can do that. Okay, Buntle, look at what we're doing here. Let me. Okay. All right, what we are doing over here is we're simplifying. So we're multiplying, multiply. Now, a over 2, if I don't know what that looks like as a fraction, I'm going to rewrite this whole thing as open brackets. I'm going to rewrite a over 2 as half times a plus 1. Then open this bracket, and that's going to be half times a minus 1. And then I can FOIL it from here. Okay, I can FOIL it from here. Now I know that a half a times a half times a half is going to give us a quarter, and a times a will give us a squared. Then I'm going to get a half a multiplied by -1, that's negative a half a. At the bottom, 1 times a half a will give us positive a half a, and the last one, 1 times -1 will give us -1. Okay, now negative a half a plus a half a will cancel. And then we've got a quarter a squared minus 1 left. Okay, so ma'am, if we get our variable as the numerator, do we also replace it with 1? Yes. If your variable is in the numerator, unless they do this, if they go, Ketelo, if they give you 2a over 3, this translates to 2/3 times a. Okay. These two things are the same thing, unless there's already a number at the top. Okay. You're very welcome. I just want to address one more question that I missed. When you're done with this one, can you please go up so I can see question 2, my phone? Okay, no problem. Here is question 2. Here's the answer to question 2 over here. I'm going to give you a chance to take a screenshot because we do need to keep moving. All right. Okay, that's all the time. Guys, if you need to take more screenshots, we'll come back at the end of the lesson. Please just make a note and I will come back for you guys. All right, let's talk about these 2 questions and then we'll talk about this next one. This is questions 4 and 5. All right, so what do we notice about question 4? We are solving for x, guys. Solve for x. That's the instruction, right? If we are solving for x, right, what is the number 1 rule? Whenever we see a quadratic, what do we always need? What is the one thing that always needs to happen when we're solving for a quadratic? Yes, we could say brackets. Yes, Buche, you're 100% correct. But compare 4 and 5. Compare question 4 and question 5 and tell me what is the difference between these two. They're both quadratics, but there's something very different about each one. Yes, Mawanda, you're correct. Yes, we need to find the factors, but what's the difference between the first one and the second one? Yes, Ethan, we will. No, not determine your ABC terms. Okay, I'm going to tell you guys so we do not forget. Tyrika, correct. 100% Catelo, that's it. This side of our equation must always equal 0 when we are solving. I already know that you guys know that it's a trinomial we're going to have to factorize, but we need to be very careful. Do you see how in question 5, there is not a 0 on this side? We need to make sure that there's a 0 on this side. Otherwise, many of you start factorizing this, which in fact is kind of factorizable, not quite, but many of you could say 5 and 2 because we're making 10. 5 and 2 plus plus. And then many of you would say this, x plus 5 is equal to 20 or x plus 2 is equal to 20. This is incorrect. We cannot do this. That's not how the zero product law works. We need to make sure that there is a zero on the right-hand side. Give me a thumbs up if what I'm saying makes sense. We must make sure that there is a zero on the right-hand side. Okay, I'm going to give everybody, these are 3-mark questions, which means you've got 6 minutes. But because the first one has already been put in place for you, I'm only going to give everybody 4 minutes. We are factorizing. We've been doing it since grade 9. It should come easily. Okay, we've all got 4 minutes. It is now 1:23. You've got until 1:27. Go for it. Kamogelo, yes, you can use the quadratic formula. Quadratic formula is mainly for grade 11, but they don't use it in grade 10 channels, not yet. It's a it's a grade 11 concept. But if you know how to use it, then you're more than welcome to. Okay, but for those of you who've never heard of it, just don't mind it. Don't mind it. Okay, Kamogelo, you're mainly going to use it in grade 11 and in your matric paper. Okay. Yes, Slay Queen.
Sorry, ma'am.
Yes.
So we've already written maths paper 1, right? So there was like a question that I was stuck on, and like I wasn't sure if I was allowed to use the quadratic formula or not, and I ended up not using it, even though it would have made my life so much more easier. And like I was just wondering if I did use it, was I going to get marked down?
Had they taught it to you?
No.
Okay, but you know how it's used.
I know the basis of it, basically.
Okay, look, maths is maths. I don't think they should penalize you for using something that's mathematically proven.
Okay.
And you could certainly contest it if you had used it and they'd marked it wrong. I think you'd be able to contest it. It's difficult. Your teachers know you have tutors. Many of them do. So it wouldn't be far-fetched for you to learn something like the quadratic formula from someone else. So I don't think it would be an issue. Okay. Feel free to use the maths that your teachers know it. Okay.
Thank you.
All right. Teacher Nelson, if you could just help and do me so out. All right, peeps, that's time. Let's have a look at question 4. All right, so for question 4, we already know that we've got a 0 on the right-hand side, so it's not necessary for us to move anything. So I'm just going to go ahead and open my 2 brackets and make them equal to 0. I should get x minus 3 and x minus 2, not plus x minus 2. So I can then say x minus 3 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to 3 or x is equal to 2. All right, 3 marks there, 1 for factorizing and 1 for each answer. All right, in this last one over here, we know we need to take our 20 over to the other side. So it's going to become negative 20. So we're going to get x squared plus 7x minus 10 minus 20 is equal to 0. And then we'll get x squared plus 7x minus 30 is equal to 0. Open up 2 brackets is equal to 0. I should get x and x. Factors of negative 30 that will give us 6 should be minus 3 and plus 10. That would give us positive 7. Therefore, x is equal to 3 or x is equal to negative 10. 3 marks because they're not going to give you an extra mark for moving things over. 1 mark for factorizing, 2 marks for each of the answers. Okay. Of these 5 questions we've just done, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Please give me a mark out of 12. Tell me how much you've gotten out of 12. No, Isabel, the questions do not matter. The order doesn't matter. All right. Okay, Manila, I don't know how you got 12 out of 23 when all the marks are out of 12, but okay. Good. For those of you who are saying you got less than 12, are we aware of where our mistakes are? We need to make doubly sure that we're not making those mistakes. Okay. So those are the small things, and these are the things we don't want to lose marks on because this is the easy stuff. Okay. This is the easy stuff. No problem, Awande. Okay. Excellent. So I'm just going to take my jersey off quickly. Probably shouldn't with the flu that I'm running. All right, let's have a look at this exponents questions next, these 2, and then we'll look at a simultaneous equation quickly. All right, so we said whenever we want to compare exponents, what do we need? If we want to compare exponents, we're going to need a what? Correct, Buche? Good. We need the same base everywhere. We need like bases. Good. Now, if we look at this particular question, we'll name it 6. What is our problem over here? We do not have the same base anywhere. Yes? So if we have to solve for this, what are we going to do? Okay, cool. Mawanda says we should factorize. I'm assuming he means we should write 36 as a product of its prime factors, which I agree with. Right. But if we go to our calculator and we click shift fact, what does our calculator say? What's going to happen? I can assure you it's not going to give you 6 squared Lwandile, but you're onto something good. Your calculator is going to say, let's rewrite 36 as 2 squared times 3 squared, right? Not 3 cubed, 3 squared, right? So we're going to get 2 to the power of x times 3 to the power of x is equal to 2 squared times 3 squared, right? So in each of these cases, we are now solving for 2 unknowns. There's a 2 there and a 2 there. And then consequently, there's a 3 there and a 3 there, right? Now, which base do we use? Because we're only looking for 1x. Which base are we going to use, 2 or 3? Mawande, why 2 and not 3? Why 2 and not 3? Because it makes sense to me. Okay, let's talk about this, guys. Let's go back to prime factors. It's okay because 2 is smaller, Faith. Okay, let's go back to prime factors. Now, if I told you guys that I had 10 to the power of x, right, and I had to multiply this with 2 to the power of negative x times 5 to the power of negative x. We want the same base everywhere. So we would take 10 and we would make it 2 times 5, right? We would go 2 times 5 all to the power of x. What would we then do with this x on the outside? Buhle, you're almost there. What would we do with this x that's on the outside there? Correct. We're going to distribute. I just want to see, somebody said, are we going to use the rule that says if the bases are the same, the exponents are the same? Yes, Lwandle, but if we have 2 bases that are the same, good. We're going to have 2 to the power of x times 5 to the power of x. right? So just give me a thumbs up if you agree with me. If I came across a question and they told me that I have 2 to the power of x times 5 to the power of x, I can then rewrite that as 10 to the power of x. Agreed? Yes or no? Do we agree with that? Because that's exactly what we've done. That's exactly what we've done with 10 to the power of x. We've just done it, okay, in the opposite direction. Nadili's like, can't you just pick the smaller number? No, that's not how mathematics works. Okay. All right. So what I can do then is I can work backwards. Okay. So Keegan, if I give you 12 to the power of x, right? And I want to multiply this 12 to the power of x with a 2 to the power of x times a 3 to the power of x. I'm going to need the same base everywhere, right? So what I'm going to have to do is I'm going to have to take 12 and split it into 2 squared times 3. 2 squared times 3. 2 squared times 3 is 4 times 3. That still gives me 12, but all of it is to the power of x. Okay. Now, because they are all to the same exponent, what I can do then is I can take the numbers and I can multiply them together. So in this case, what they've given us, Keegan, is they've given us 2 squared times 3 to the power of x. What I'm going to do is I'm going to take the thing in the middle and I'm going to multiply it together, and all of it will be to the power of x. So it's sort of like I'm working in reverse to get back to 12 to the power of x. Now, if I do that over here, guys, what am I going to get? They both have the same exponent. Do we notice that? If I now have to put them underneath one exponent, what am I going to get? Yes, Nell? Nell, I see your hand is up, my sweetie. Is there anything we can do for you?
Yes, ma'am. How are you, ma'am?
Hello, I'm good. How are you?
Yes, I just wanted to ask, like, what happens with the eggs if don't they like add up?
No, because the bases are not the same. This is a 2 and this is a 3. Okay, so we can't just say now we're going to add the exponents. That's not how it works. But think about this. They've given us 2 separate numbers with the same base. Yes?
Yes, ma'am.
Okay. So they've given us 2 to the power of x times 3 to the power of x. Do you see how they both share an exponent of x?
Yes, ma'am.
So what I'm going to do is I'm going to take both of these numbers and multiply them together. What's 2 times 3?
Should be 6.
To the power of?
X.
Just x. Good. Because they share a common exponent, I can multiply the bases. Okay, same if I had 2 to the power of x times 5 to the power of x. How else can I express this now?
It should be 10 to the power of x, right, ma'am?
That's it. Correct. Right.
Oh,
so now
I understand.
Are you with me? If I take
Yes.
2 to the x times 3 to the x, you just said it's 6 to the power of x. What can I do on this side with the 36 to make sure we have the same base?
And you should be like, what is
How else can I rewrite 36 to make sure it has a power or it has a base of 6?
Don't you like root it? It should be you square root.
Square root, or I can express 36 as 6 to the power of what?
6 to the 6 squared. I mean, to the power of 2.
6 to the power of 2. Now that I have the same base, I can drop my bases. And what is x equal to over here now?
X equals to 2, ma'am.
Good. That's it. Beautiful. Well done.
Oh.
Okay. Are we seeing what math is done here?
Yes, ma'am. Thank you, ma'am.
Okay. Now, logic dictates that the other way we did it isn't wrong either. Okay. In that other one where we took 36 and we wrote it as 2 squared times 3 squared, it's correct. That just means that x is equal to 2 in both instances. X will be equal to 2. But we need to make sure that we are following the steps that we're taking. Because if we end up with a question that does not work out like this, then we're going to have a bit of an issue there. All right, Siamtanda, what's up?
Ma'am, I just have a question regarding this question. So basically, if we start off changing 36 into 6 squared actually, then on the other side, we do your method, it's still correct.
Yes, it is.
Okay, thank you, ma'am.
It is. Okay. But the thing is, Siamtanda, sometimes they'll give you a question that looks like this. You will have 3 times 5 to the power of x is equal to 45. Or let me not say 45. Let me see. Is equal to 75. Okay. Can we then, in this question, in fact, let me write it down here. I'm going to write it out over here. If I have 3 multiplied by 5 to the power of x is equal to 75, right? What's missing? Okay, let's compare the two. Let's compare them. What do we notice?
There's no 3 to the, there's no power x on the 3.
Correct, that's it. There is no power to, like, there's no to the power of x here, right?
Yes,
so can I then say 3 times 5 is equal to 15 to the power of x is equal to 75? Can I do that?
No, ma'am.
No, I can't do that because I don't have the same exponent. The only reason I'm allowed to multiply these two is because they both have the same exponent. Okay.
Okay, thank you, ma'am.
I hope I answered your question. I hope I answered your question correctly.
Very well, ma'am. Thank you, ma'am.
All right. Okay, so there's a distinct difference here, guys. In this case, I would have to divide both sides by 3 and then solve 5 to the power of x is equal to 25. Now I can solve for x. But in this instant, because they both have to the power of x, I can multiply them together. They both have the same base. Now, oh, thank you, teacher Nels. Yes, good. Yes, equations are fun, Mawande. Agreed. All right, let's talk about this one over here, number 7, and then we'll also talk about the simultaneous equation in just a bit. Okay. When we look at question 7, okay, we want to make sure we have the same base because the thing we want is an exponent. Our x is in the exponent. So what are we going to do on each side? What's our steps? Okay, Landile's already given me an answer. I want Landile to explain how we get to that answer. Correct, teacher Nels, you can multiply, yes. All right, let's think about it. How else can we express 27? How else can 27 be expressed? Good, yes, correct, Mawande. We can rewrite 27 as 3 cubed, good. But the problem is, if this is to the power, if this has a base of 3, how else can we write 1 over 3 so that it also has a base of 3? Remember, we need the same base on both sides. Correct, Tyrika, that's it, 100%. 100%. We know that we can rewrite 1 over 3 as 3 to the power of -1. So we're going to have 3 to the power of -1. All of that to the power of x minus 1 is equal to 3 to the power of 3. All right, and again, we have a bracket with an exponent, so we are going to distribute that -1 in. All right, I can trust you guys to solve for the rest of this for me. You've got 2 minutes. Pop your answers in the chat when you're ready. Okay, double check. Yes, somebody's asking if they can move on to question 8. Yes, if you're already done with this question, please keep moving. Okay, for those of you getting -2, you are spot on. The others, please just check the way you're transposing your numbers. Make sure that we're doing them in the correct order. All right, Gimukuku, double check again for me, please. Oh no, everybody getting -2. Please double check your answer. No. Yeah, everyone getting -2 is correct. Everybody getting -4, please double check your answer. All right, so over here, I should get 3 to the power of -x plus 1 is equal to 3 to the power of 3. Now that my bases are the same, I can drop them. Okay, so I'm going to get -x plus 1 is equal to 3. The positive 1 will go over. I'll end up with -x is equal to 3 minus 1, which is 2. Therefore, x must be equal to -2. Okay, that's the final answer we should get for that one there. All right, let's talk about the simultaneous equation. Give me a thumbs up if you can solve for the simultaneous equation on your own, or give me a thumbs down if you're going to need my help. Okay, for those of you giving me thumbs up, carry on. For those of you giving me thumbs down, we're going to give it a minute, give everybody else a chance to answer the question, and then we'll come back to it together. All right. One more minute, guys. Move it over to the side just now. All right, peeps, that's time. Let's have a look at this question over here. Okay. All right. So when we are solving for two things simultaneously, there are two possible ways that we can do this. We can either solve, by elimination. Phew, my words are escaping me. We can either solve by elimination, or we can solve by substitution. Okay. Now, in this particular question, I'm going to use substitution. And the only reason I do that is because I can already see one of or both of these values in my first equation have a coefficient of 1, which makes my life a little bit easier because I don't have to divide by anything. So what I'm going to do is I'm going to choose whether I want to make A the subject of the formula or B the subject of the formula. My first step is always to name these. So I'm going to start by going A plus B is equal to 12 is going to be my equation 1. And then 4A plus 2B is equal to 44 is going to be my equation 2, right? So I want to then solve for B first. So I'm going to make A the subject of the formula, right? So what I'm going to then do is I'm going to take B, move it over to the other side, and I'm then going to get from equation 1, I'm going to get that B is equal to 12 minus A, and I'm going to name that equation 3, right? My next step is then to sub equation 3 into equation 2. So in equation 2, wherever I see a B, I'm going to replace it with 12 minus A. Okay, so I'm going to take equation 2 and I'm going to go 4A plus 2 times, now there's a B, so I'm going to replace that B with 12 minus A. 2 times 12 minus A is equal to 44. Now we've only got A's that we're working in, so we can then solve for A. So I'm going to multiply this in over here. I'm going to get 4A plus 2 times 12 will give me 24. 2 times negative A will give me minus 2A is equal to 44. Then we can just move things over from one side to the next. I'm going to take my 24 over to the other side and it's going to become minus 24. 4A minus 2A will give us 2A. So I'll have 2A is equal to 44 minus 24 will give us 20. Therefore, A is equal to 10. Okay, all right. Now that we have A, we can just go back into our original formula, into question 1, and we can sub in for A. So we're going to sub in 10 for A. So we'll get from equation 1, 10 plus B is equal to 12. 10 plus what equals 12? 2. So therefore, my B must be equal to 2. Thank you, Keegan. It's actually, I've got a flu, so that's why I'm sounding so groggy and the such. Okay. All right, give me a thumbs up if solving simultaneously is okay. Are we all okay here? Yes, it's a 5-mark question though. It's a 5-mark question. Well, I think it's 4 now, but last I checked it was 5 marks. But yes, about 4 or 5 marks. Okay, Farine, where did we lose you? Where did we lose you? Okay. Okay, just DM either me or teacher Nelly, or I'm going to have to come back to it at the end of the lesson, okay? Mawande, yes and no, because in most exams, there's only one simultaneous equation. So you can't just, the whole thing isn't simultaneous equations, just there's only one question. So you also need to understand the rest. All right, so for those of you who were here on the first lesson that we did on paper 1, this is the Venn diagram that, or the question on probability, no problem, that comes from that question. Somebody's asking if it's okay that they solved for B before they solved for A. 100% correct. Okay. There's a yes. Funzo, it is possible for you to minus one from the other, yes. But that one becomes a little bit more complicated. Then you've got to take equation 1 and multiply it by 2, and so on and so forth, and it becomes complicated. It's really complicated. Okay, Kamogelo, that's okay. Okay, I'm gonna ask you to just maybe sit this one out. I'm surprised that they haven't done probability for you guys. That's okay, Funzo. If you know how to do that method, you can do it. All right, let's have a look at question 6, guys. I would like you guys to answer these questions here for me. 6.1.1 up until 6.1.2. Please give me a thumbs up in the chat if you know what to do all your own. Give me a thumbs down in the chat if you'd like a little help on what to do. Sure. Like I swallowed a bug. Ugh, not a good feeling. All right, I'm only getting 1 thumbs down and no other responses. So I'm going to ask you to wait until we go through the question together, okay? Which is going to be in the next 3 minutes, and then we'll have a talk. Okay, Tams and YouTube. Yes, Fundo, and that tells you what? Yeah, that must tell you something. Excuse me. Katelo, almost there. You missed something quite important there. 1 more minute. All right, peeps, that's time. Okay, let's talk about this Venn diagram. I'm going to move over to the side over here and plop down the information that we needed. All right, it says 500 passengers were asked what their preferred mode of public transport was. The following information was recorded. We need to put this on a Venn diagram. I know that I'm going to have my sample space. My sample size, I've been told that my sample size is 500. Right, I know that there are 2 modes of transport, but as Mfundo has already alluded to, there's 524 of them when you add them. That tells me that there is an intersection, and I don't know why I'm drawing the intersection with. There we go. That tells me that we're going to get an intersection in this particular question, right? So I'm going to name this part T, and I'm going to name this part B. Right, this is for public taxis, and this is for the bus rapid transit. Now, I already know that 2 people preferred neither, so those 2 people need to go outside my 2 circles. They're going to sit on the outside. Now, they said 342 people preferred public taxis, 180 preferred bus rapid transit, but they don't tell us how many of them preferred both. So that means my intersection over here must become X. My intersection in the middle must be X. Now, if public transport or public taxis is 342, and I know that X amount of them has already been accounted for, those who like taxis only is going to be 342 minus X. And if I know that 180 of them prefer the bus, and X of them have already been accounted for, those who like bus only need to be 180 minus X. All right, now I know that all of this together needs to add up to 500. So I'm going to go 342 minus X plus 180 minus X plus 2 is equal to 500. Now, negative X plus X will cancel, give us 0. So I'm going to get 342 plus 180 plus 2 is going to give us 5. Oh, sorry. Yes, Mfundo, sorry. It's going to give us 524 minus X is equal to 500. So I'm then going to take my 524 over to the other side, and it's going to become negative 24. So I'm going to get negative X is equal to 500 minus 524, negative 24. Therefore, X is equal to 24. Now, what this tells me is my middle part over here, my intersection is 24. That means taxis only needs to be 342 minus 24, which gives us 318. And on this side, for buses only, we should get 180 minus 24, which should give us 156. Okay, if we add all of these numbers up together, they should then give us 500. Give me a thumbs up if the method ma'am just went through makes sense. Are we all okay with this? Excellent, good. All right. Now, if you haven't quite done yours yet, thank you, Kimotoko. Excellent. All right. If you haven't done your Venn diagram yet, I want you to take a screenshot of this one because I'm going to pan back to the questions and we need to answer the questions using the Venn diagram. Or if you'd already drawn one, but it's not filled in, just make sure that you're filling it in very quickly before I continue with the questions. Okay. All right, let's go have a look at the questions over here. It says, if a pedestrian is chosen at random, determine the probability of the probability of T something with B. This sign here in the middle, this upside down U, this is the intersection. And we know how many people are in the intersection, right? There are 24 people in the intersection, but because it's a probability, this needs to be 24 over 100, 500. 100. Okay, good. 24 over 500, that's the answer we're looking for. Right, the probability of the union of T union B, union would mean everything in my circles except what's not outside, what's on the outside of my circles. So that's everything but everyone but 2 people. So the probability of T union with B would be 498 over 500. Now, I want you guys to note, I haven't simplified these. You must simplify. Okay, punch that into a calculator, get a simpler answer. I think this one is like 6 over 125. The first one should be something like 6 over 125, correct? Good, 6 over 125 And this one is an ugly number, like 290 something over 250. I can't quite remember where 498 is at. Okay, but we also need to find the intersection, sorry, the simplified version of that. Oh, 249 over 250. Okay, 249 over 250. All right, now in this next one, it says the probability of not T's union with B. So let's go have a look at what is not part of T. Now, I know that my taxi people are all of those people, right? So everybody who is not here, the union of that with B, I will go back in just a second, give me a sec, right? So it's going to be the union of everything that is not in T. At the moment, what is not in T? 2, and B would be 156. Okay, I will explain now. So we should get 156. Do not forget the 2 on the outside, because that is also not in T. Funzo, are you understanding what I'm saying? The 2 on the outside is also not in T. Okay. So we should get 158 over 500. Okay, over here, we should get 158 over 500. Okay, which can also be simplified. We always leave the answer in simplest form. All right, Kibututu was just asking me, ma'am, how do we get 498? Okay, if we look at our, union is going to be everything over here. Our union is going to be everything in T, including everything in B. That's our union. Right. Now, if we count up all of those numbers, the only number that's going to keep us from getting to 500 is that 2 on the outside. So that means that the union of T and B altogether should be 498. Okay. Because everything in both those circles adds up to 498. All right. And thank you, somebody, for simplifying that for me, 79 over 250. Thank you, Funzo. Thank you, Funzo and Stephen, for simplifying that for me. Okay, excellent. All right, let's have a look at this next question that they've given us down here. Okay. No, Nico. Think about this, Nico. If they said to you, what is the probability? We're looking for the probability of not T. What is there that is not in T? The thing that's not going to be in T is B, the whole of B, and the 2 on the outside. They're both not in T. Okay, both of them are not part of T, so we need to consider them both. The union with B would still be included anyway, because it's already not part of T. Okay. So we must take both of them, because 2 is not part of T either. Okay. All right, good question. All right, let's look at this question down here. Now, this last question, 6.2, is going to require us to remember our product rule and our addition rule. I'm going to write them down here for you. We know that the product rule says that the probability of A and B should be equal to the probability of A multiplied by the probability of B. That is the product rule. Okay. 500, it's 500, Farine. Sorry, my handwriting is terrible. It's 500. Okay, and then the addition rule says if I want the probability of A or B, I should then take the probability of A plus the probability of B minus the probability of A and B. Okay, that's very important. So we're going to need both of these to solve for each of these. All right, so let's look at the information that we've been given. They say here, 2 events A and B are given. They give us that the probability of A is 0,4, the probability of B is 0,3, and the probability of A and B is 0,1. Then they ask you to use the rules of probability to determine the probability of A or B. Which rule are we using? Are we going to use the product rule or the addition rule? Product or addition, guys? Good. Funzo, I guess when you say number 2, you mean the 1. Yes, good. We're going to use the addition rule, and we're going to use it the way we would an equation. Okay, we're going to use it the way we would any other equation. All right, so they want us to figure out what the probability of A or B is. Right, so we're going to use the addition rule. We're going to go the probability of A or B is equal to, we have the probability of A. The probability of A is 0,4 plus the probability of B is 0,3 minus the probability of A and B, which is 0,1. 0,1. Okay, what answer do we get there? You can pop your answers in the chat. Zero comma 6, correct. That's it, Kimotolo, excellent. Our answer is 0.6. All right, that's 6.2.1. All right, let's look at 6.2.2 quickly. All right, it says here, what is the probability of not A? What is the probability of the complement of A? Okay, remember that the probability of not A is just the same as 1 minus the probability of A. So for 1 minus the probability of A, we should get 1 minus the probability of A is 0,4. That means that the probability of not A is going to be 0,6. All right, now let's go look at 6.2.3. It says here, we want the probability of not A or B. The probability of A or B not. Not. What is that going to equal to? That's going to give us the probability, 1 minus the probability of A or B. The probability of A or B. But we've already calculated for the probability of A or B. What was the answer? 0.6. So the probability of A or not A or B is going to be 1 minus 0,6, which is equal to 0,4. All right, thumbs up. Are we okay with this particular exercise? Because we're going to move on just now. Are we all good? Excellent. Now, I just want to reiterate that sometimes in your paper, what they do is they give you the probability of A or B. They give you the probability of A or B, but you're still going to have to use the addition rule to figure out the probability of A and B. But because it's an equation, we can just move things around. Okay, we can shift them around every now and then. Ramrata, what's up? Hi, Ramrata. Okay, she's not unmuting at the moment. We'll wait, Ramrata. When you're ready, you can unmute, but we're going to continue. I will take your question then. Farin, I'm not 100% sure why they wouldn't teach you this. It is a fundamental of the grade 10 CAP syllabus, so I'm not 100% sure why. And if you go to an IEB school, you most definitely have seen this possibly in grade 9 and not in grade 10. But yeah, we can talk about that. All right, here's the next part. We're going to look at paper 2 questions. Here is your first question, guys.
Okay.
Hello, ma'am.
Sweetie, what's up?
Ma'am, it was a mistake. Yeah, I posted by mistake.
Okay, that's fine. That's fine. I'm just gonna mute you, okay, my sweetie. By angles, you mean which angles? I'm not sure which angles you're referring to. B2 and 1 and D2 and 1. Are they correct? I mean, they don't have values, so I don't know in what sense you're meaning, but oh, I don't know. You have to prove that. You can't ask me to answer the question for you. You must answer the question for yourself. If I say yes, I've given you the answer. If I say no, I've given you the answer. I can't give you the answer in the middle of an exam. You must know whether it's correct or not. Okay, 1 more minute, guys. Always, Pascal, always. Funzo, don't give away the answers. All right, Mwande. All right, peeps, that's time. Let's have a quick look at this one. All right. So it says here, use the diagram below to prove that opposite sides of parallelogram are equal, i.e. that AB is equal to CD and AD is equal to BC. Now they're telling you what to do. I shouldn't actually have given you guys a hint, but I've given you a hint. To do that, we must prove that triangle ABD is what? What does that sign in the middle there mean? How can we prove things when we need to prove things that things are exactly equal? Good. We are not proving similarity. We are proving congruence. When we are looking to make sure that things are equal, we must prove congruence. There's no other way around it. We can't prove similarity. We must look at the fact that they should be 100% correct. Okay, so we're going to start our proof. We're going to say proof in triangle. Now, guys, I cannot emphasize again how important the order in which you write your triangles is. Okay, look at the order that they've given you. We must write it as in triangle A, B, D, and triangle C, D, B. In that order, So they've started at A, then they've moved along the long side, and then down the middle, and then they've moved down the middle and then back to the beginning, which means on this other side, we must start on the obtuse corner, take the long side, and then come up the middle and then back down. Okay, so we must do it in the same order that they do it in order to know which triangle goes with which. Now, that means that if I decided that I was going to write the first triangle as ADB, what would my other triangle be? If I had said in triangle ADB, how would I map out the next triangle? And triangle what? Good, Buche. Because I started at the obtuse corner and I went down and then through the middle. In this case, I need to start at the obtuse corner and go up. So I must say C, B, and then down the middle to D, and then close my triangle. The order must be correct. And I'm going to show you why that order needs to be correct in just a minute. All right, let's prove congruency quickly. Okay, let's prove congruency. So we know that arrows mean what? What do arrows tell us? Arrows are what lines? Good, parallel lines, not equal. Arrows mean parallel. And whenever we see parallel lines, we must think what? Good, Buche, that's it, Funzo. Whenever we see parallel lines, we think of fun angles. We think of fun. Remember, guys, fun. This is corresponding. U is co-interior. And N is alternate angles. So we must see those, okay, as we go. All right, we must be looking for those as we go. All right, so I'm going to start with B2 because Funzo has already given it away. B2 must be equal to D1 because of alternate angles, right? B2 is equal to D1. And our reason is alternate angles, and we must name the parallel lines that do the thing that we need them to do. All right, so we found these two alternate angles using AB and CD. So I must then say AB is parallel to CD, and I'm going to show you why that's important in just a second. We know that B2 is equal to D1. We also know that B1 is equal to D2. Correct, Mawande? Good. We know that B1, angle B1, is equal to angle D2, but this is also alternate angles, right? But this time, which two lines did we use? We used AD as our parallel line, and we used BC. Now I'm moving the whole page. Give me a second. And we used BC. So when we say alternate angles over here, our two parallel lines will be AD is parallel to BC. So it's important for us to remember where we've gotten these parallel lines from and where these alternate angles stem from. Okay. Yes, Nico, but that's what we're trying to prove. Yes, thank you, Teacher Nels. Okay, good. And the last step, which many of you have already alluded to, is that BD is common. Right, I've got my three reasons, 1, 2, 3. That's enough for me to prove congruency. So I can say, therefore, triangle ABD is congruent to triangle CDB. What is my reason in this particular case? It's not angle side. It's not angle side. Okay, think about it. I've proved an angle right next to a side and another angle. It's not side. We've only got one side, Naledi. This is an angle. I actually forgot to write here. This is an angle. This is an angle. This is a side. But look at the order in which they are on the actual drawing. Yes, Kimukulu. Kimukulu is in fact correct. There's an angle, and a side in between the two angles. There's a side in between the two angles. So my reason should be angle, side, angle. All right. That is the proof that we're looking for. Mawande, we must say common. Okay, it's basic nomenclature. All right, we must say common. All right, now what this shows us, guys, is that the corresponding sides in the way that we've written our triangles matters. Yes, Keegan, it does. It does. Okay, so, or do you mean the order of the proof? No, the order of the proof doesn't matter. Okay, now we're going to say that side AB is going to be equal to side CD. And that's why the order in which we wrote them is important. Because we've proven congruency, then we can say that, therefore, AB is equal to CD. We can also then say that side BD is equal to which other side? What is side BD equal to? to DB, correct. But we already know this because line BD or DB is common. It's common. And then the last one is going to be AD. So first and last is equal to first and last. Therefore, AD and AD is equal to BC or CB. It won't matter in which order we write it. BC or CB, same thing. There we go. Now we've proved what they wanted us to do. We can come to our conclusion. Therefore, ABCD is a parallelogram. It's a palm. Opposite sides equal. And that's how you get your 4 marks. All right. Are we all okay with this? Thumbs up if we're understanding how to prove for quadrilaterals. All right, excellent, peeps. Okay, let's look at this next question. All right, this is a measurement question. I want you guys to have a look at it, read through it, and answer it the best way you can think. And I'm going to emphasize, this is a level 4 question. So you find this at the end of your paper. Okay, so think a little bit outside the box. Let's think a bit logically, guys. Okay, you can pop a thumbs up or any emoji you would like in the chat once you think you've got an answer for us. Oh, Kamachelo. I'm very sorry about that. And the reason I'm sorry about it is because things like this, especially this type of question, you are 100% going to find a question like this in your matric paper. So it's very important that we understand measurements. Okay, it's part of a section called optimization that we do in matric. Mfundo, can I ask you to rephrase that? It's not quite making sense to me. Just rephrase for me, please, because it's, yeah. I don't know, Naledi, is it? Because if you ask me that question, you're asking me to answer the exam question for you. I do that to my boys all the time. And they get very mad at me here at my school. They'll be like, ma'am, we have to use pi equals r squared, right? Pi times r squared. And I'll be like, I don't know. I don't know. You can't ask the teacher for the answer while writing a test. There's no mara, ma'am. No. Figure it out. One more minute. I'm sorry, Mfundo, I'm not there over your shoulder while you're writing your exam, unfortunately. All right, peeps. Okay, that's time. We're going to have a look at this question. Now, the most important thing to always do when we come to a question, guys, if they give you a write-up, it is very, very important for us to read the write-up. you could miss so much information if you do not read this write-up that they've given you. So we must read what it says. Okay, so it says here, the cylinder in the diagram below has the diameter. So you see, instead of asking, ma'am, is 4x the diameter? If we had read the beginning, Naledi, we would know that the diameter, it has a diameter of 4x units. You wouldn't have to have fought with ma'am over that question. It literally tells you there that it is a diameter and a height of h meters. All right, then we go to our drawing and we look, okay, they've given us the diameter of 4x and a height of h. Good. The cylinder is open at the top, which is a very, very important statement that they've made over here. It is open at the top, and the total surface area of the cylinder is 32 pi meters. Now it says, calculate the height of the cylinder in terms of x. Now, they've given us the surface area. And whenever we want to calculate for the surface area of a shape, we need to break it up into its parts. What two shapes is this cylinder made of? What two shapes? Good, Mfundo, it's made up of a circle and a rectangle, correct, Funzo. So we know that we would have a circle at the top, and we would have a circle at the bottom, and then we would get, okay. Yeah, that's ugly. That's not the way I wanted that circle to come out. And then we would get a rectangle in the middle, right? We would get the rectangle that goes down the middle. However, what do we know about this particular cylinder? Do I need two circles? Correct, Siamtanda, it's open. So I don't need both circles. I only need the bottom circle because the top circle isn't there. The cylinder is open. So if I wanted to calculate for the surface area, I'm not going to take the area of my circle and multiply by 2. No, I'm only going to calculate for the area of one circle and add that to the area of my rectangle. Okay, now let's talk about our rectangle. I know that the breadth of my rectangle is my height. How do I then find the length of my rectangle? What is the length of my rectangle over here? What is it going to be? We've spoken about questions like this before when we did the measurement section. How are we going to find the length of our rectangle? Okay, for those of you who can't remember, and because we are running out of time, it is the circumference. It is the circumference of the circle, which is the same as pi times diameter. All right. Excuse me. Okay, so it is the circumference, correct, not the diameter. Well done, Siamtanda. It is the circumference that we're looking for. Just give me 1 second. All right, it's the circumference. So we're going to then calculate for the surface area of this thing. Now, they've already given us the surface area, but for now, let's pretend we're actually calculating for the surface area. I'm just going to move over a little bit. Okay, so if I calculate for the surface area, I'm going to get the area of my circle, which is going to be pi times, what is my radius? What is the radius in this particular question? 2x, correct, it's 2x. Because our diameter is 4x, our radius will be 2x. So I'm going to get pi times my radius, which is 2x all squared, plus the area of my circle, which is my height h, multiplied by, oh, sorry, my breadth h multiplied by my length, which is pi multiplied by 4x. Mfundo, was that your question earlier? Okay, maybe I didn't quite understand. So yes, you were right. Okay, good. So now let's clean this up a little bit, guys. I will. Thank you, Pascal. Let's clean this up a little bit. They've told me that my surface area is 32 pi, and they want them to give an answer for the height in terms of x. So basically what they want us to do, guys, is they want us to take this answer we've got here. We're going to go through a couple of steps, and at the end, we must have an answer that says h is equal to something. And that h that it's equal to must come with x's in it. The answer will have divided by x plus x minus x. There'll be an x in the answer that we get. So we're going to use literal equations to find this answer. So here's what we're going to do. We're going to replace our surface area with 32 pi is equal to, now 2x all squared is the same as pi times 4x squared plus pi times 4x times height. Pi times 4x times height. Now, I want my height to be the subject of the formula. This part over here does not have an h. So I'm going to take that whole thing over to the other side. Give me a thumbs up if you understand why ma'am is doing that. Are we all good? Okay, Pascal, I want, if I said to you, I've got 8 is equal to 3 plus 3x. Okay, let me make this 2, otherwise it's awkward. 2 plus 3x. And I said solve for x. Do you agree that the 2 must go over? Yes? Yes, because the 2 doesn't have an x. It doesn't have an x, so it must go over to the other side. We only want things with x's on the side. And because in this equation that we're solving for, we want h on its own. So that means anything without an h must go where? Anything without an h must go to the other side. Okay, so I'm going to get 32 pi, yes, next door, minus 4x squared pi is equal to pi times 4x times h. Now, here's what I'm going to do next, guys. I'm going to look for a highest common factor on this side, on the left-hand side. What is my highest common factor here? What do they all have in common, those two terms? What do they have in common? Pi and 4, correct. They have 4 pi in common. So we're going to take 4 pi out, and we're going to end up with 4 pi, open brackets. This is going to become 8 minus x squared, which is equal to pi times 4x times h. I want h on its own. So what do I need to do to get rid of pi times 4x? Good. We need to divide. We're going to divide by pi times 4x on both sides. Divide this side by 4 pi x. I did that deliberately. I'm writing it in that order deliberately. Okay, good. We're going to divide. So those two will cancel. Now I've got h left on its own on the side. So I'm going to say h is equal to, now 4 pi and 4 pi will cancel. So what I actually have left over is 8 minus x squared all over x. That's my final answer. Okay. Scale of 1 to 10, how do we feel about this question? Because on a scale of 1 to 10, 1 being nope, 10 being, I could have figured this one out myself, man. Okay, those of you who said 0, how? How? Okay, so minus 744. Thank you, Jesus. Okay, guys, remember these kinds of questions. These kinds of questions are those questions that you guys leave the exam room and you're like, yo, Chomi, what did you get for this? What answer did you get for this one? I got 15. Everybody got 15. Somebody else got 2, and you're the only one who got president as an answer. It happens, guys. It happens. This is one of those questions.